In this problem, we're given information about passenger cars and commercial trucks. So I'm going to start this problem by just writing down the sample information that we have. So we have our passenger cars, and we know that there are 233 who have only rear license plates. Out of the total number of passenger cars, 2,175. And we're going to compare that to commercial trucks. And in that case, X is equal to 48, and that's out of 321. So I need to designate one of these as group 1 and the other as group 2. So since the passenger cars came first, I'm going to call that group 1. So I make that X1 and N1, and then for commercial trucks, X2 and N2. So when we're looking at P1 versus P2, our null hypothesis is that P1 is equal to P2. And the alternative hypothesis, I need to look at the claim now. So let's see, what is it that we want to test? It says a reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. So we want to say that P2, the rate of commercial trucks that don't have a front license plate, is greater than P1. So I'm going to write that as P1 is less than P2, to just keep that in order 1 first and then 2. So that's our null and alternative hypotheses. And now, because these are, we're comparing two proportions, so we're going to use 2-prop z-test in your calculator, and we're going to put in all of this information. So we have X1 is 233, N1 2175, X2 is 48, N2 321, and our hypothesis is that P1 is less than P2, and then you can either choose calculate or draw. And we get our test statistic is negative 2.24, and our p-value rounded to 3 places is 0.012. So now I look for alpha, and that's given here. It says alpha is 0.05. And that is larger than our p-value, which means we want to reject the null hypothesis. So when you reject the null hypothesis for this particular case, then we want to say there is sufficient evidence to support the claim because our claim was the alternative hypothesis. So we want to use the word support because of the claim being the alternative hypothesis. And there is sufficient evidence to support the claim because we rejected the null. So we said no to the null. We like the alternative hypothesis. So there is sufficient evidence to support the claim. And then you just give what the claim is. So that's what we've got here as our solution. Now, to identify the confidence interval limits for to test this hypothesis, what we're going to do, I'm going to clear out this information, and now we're going to do a 2-prop Z interval because we want a confidence interval. And you already have the sample information in your calculator, and it will keep that information. What we need to know is what confidence level to use. So let's take a look at our distribution here. And I'm coming back to the original null and alternative hypotheses. This is a left tail test, which means that alpha, which was 0.05, our significance level alpha, we have 0.05 or 5% in the left-hand tail. Now, because we want to find a confidence interval, we need to balance that 0.05 on the left with another 0.05 on the right, or 5% on the right. So we make those match, and so my confidence level then is going to be 90%. So when I do my 2-prop Z interval, I put in x1, n1, x2, n2, just as we did before. And as I said, you don't have to retype this because it's already in your calculator. And then you give your confidence level, and that is the 90%. And when you do that, you get your confidence interval of negative 0.0769 to negative 0.0079. And that's how you do that problem.